welcome back. How's everyone doing? Good evening last night? Were we asking a lot of questions? Remember what I said about curious minds? You know, it's interesting when you do this and you go to a lot of conferences, who's asking more of the questions? Who's asking more of the questions? You know, one thing, when Tony Fadell was backstage yesterday, 20 minutes before we got started, you think a brilliant mind like that, he'd have a lot of things to say. But you know what he was doing? He was asking everybody everything. And maybe he would identify his next startup, or maybe he was just going to identify the next trend, or maybe he's just curious. Curiosity is the key to brilliance. It's not having all of the answers. It's also very attractive. You know, they say you're a great conversationalist when they're doing all of the talking. Right? Remember that. Yeah, if you're in a conversation and they're doing all of the talking, later they'll say, she was a great conversationalist. But it's also about finding innovation. You've got to be asking the questions. You've got to have the curious mind. I really believe that. And I know I get stuck often in talking. Somebody asks me a question and I get into it. At some point, stop and ask the question. Be curious for the rest of the day today, and I'm sure you're going to take a lot out of it. So we had a selfie competition yesterday. The winners of the selfie competition are Johannes Maurer, his post on Instagram, and Jinje Lee, his post on Facebook. Okay? Now, today we promised you another competition. Here's what you have to do today. Today, take a photo of your favorite thing at the summit and post it with the hashtag SummitFave. Hashtag SUMMITFAV. Post it on Facebook, Instagram, Twitter. You know, maybe your favorite thing is a person. And maybe if you show curiosity, you'll be somebody's favorite. The winner will win a Zeiss headset. So, photo of your favorite thing at the summit, hashtag SummitFave, Facebook, Twitter, okay, Instagram, etc., and maybe you can win. Okay, so now on to our show for today. Our first speaker today, Roland Siegwart. He's a professor at ETH Zurich. He is in the area of autonomous mobile robots. He bridges academics and startup initiatives. The talk today, Bridging the Gap, the era of AI. Roland.
Welcome.
Over to you.
Morning. Good morning, everyone. So I will today speak mainly not about bridging the gap era of AI, but mainly bridging the gap between the data and information world with the real world, and one of these tools and machines are robots. Let me recap something everybody knows. About 35 years ago, the PC started to appear in our environment. Then the internet allowed us to share the information we had first on our computers, and then the smartphone allowed us to always get access to information. All this really has a huge influence on our society, on our way how we live every day, how we interconnect with people, how we work. But what all this field covers is mainly a virtual world of data and information. And the only real interaction with the real world up to now was humans. We had access, we could feed in information and get out information. This virtual world had still generated a lot of new companies, and some of these new companies are now the biggest and most valuable companies in the world, like Google, Facebook, Microsoft, and so on. So the next step in this evolution or revolution is actually connecting the data and information world with the real world. This is very often under the title Internet of Things or Cyber-Physical Systems, which I like most, or robotics. And connecting the data with the real world is much more difficult than only being in the data world, because you have to deal with the real complexity of the environment. So I would like to start with this video, which was recently posted on YouTube from Boston Dynamic, which is a company owned by Google, which shows more or less that obviously just around the corner there will be robots which help us in our daily life and clean up our kitchen. This would be wonderful, and I would be very happy to have these devices at home. But what we have to actually understand, and it's written actually within the YouTube posting, that this is mainly operated or pre-programmed. What these robots can do, they can get on their legs, they can really nicely move their legs and their arms, but what they cannot do today is really understanding, for example, the big mess in your kitchen or at your home, and really do an outstanding job as we humans do it. So in contrast to the digital and the information world, where we scale up extremely fast by doubling the computational power and memory every 18 months with the Moore's law, the real world environment is quite different. It's governed by physical constraints, by the limitation of the physics, and even if a lot of people, especially also in Silicon Valley, would like to dream to have tomorrow fully autonomous cars which can do everything in all situations, it's much more difficult than they think, and they will also not be able to change this. So in order to really do interaction in your daily environment, as a robot, as you can see here from Willow Garage, which actually sped up by 50 times, so it's still pretty slow, and it's still pretty limited, these robots have to be able to perceive the environment. They have to be able to understand the environment with all the uncertainties and also partial knowledge you have. They have to not only see it, but they also have to feel it and to interact it. And for doing so, they need force sensors, they need torque sensings, they need also torque control motors so that can act with forces on the environment. Today, industrial robots act actually only on position. They can very precisely position their arm, but they are not able to really precisely control forces acting with their arms. And of course, these machines have to have interface where it's easy to control them, so just tell them, bring me a beer, and then it should be go and bring a beer in whatever situation. If you start to think about what this means, what the process you as a human do to find a beer in a new place where you have never been, where you have no clue where the beer is, then you probably realize that it's quite complex, and for us it's daily life, and we are probably not realizing how complex it is. And of course, these systems have to learn and adapt with their task in their environment. So let me first start with two examples also about robots design. And robots or machines which physically interact in our daily environment, they have to be first adapted to their tasks. And we have a lot of projects with students, but also with PhDs and postdocs, trying to find new ways how to build robots and generate robots which can do tasks which are not feasible today. One example, this is a student project, the Vertigo, where the student had a task to design a robot which can not only roll on wall, but can on ground, but also on walls and ceilings. And what they did actually propose is somewhat a hybrid between flying and wheeled. It's a four-wheeled robot. The wheels are not actuated, but the front wheel is steered. And then you have a propeller, like in a helicopter, which can generate forces. And these propellers are on the gimbal, so they can be oriented. So with this, you can generate a force against the wall. You can generate a force which is acting against gravity, and a force which actually propels the whole system. And then what you can do with these robots, you can go on walls. Now, this is, first of all, something fun to see, but on the other side, it allows, for example, then to inspect bridges to see if there is something wrong with the concrete there, and allows to go to places where typically robots and humans cannot so easily go. The second field is today most mobile robots are on wheels, and wheels are limited to flat grounds. As soon as you have a stair, it's very difficult. If you go to mountains, whatever, it's even more difficult. Nature evolved animals, but also humans. We are extremely good in quite different terrains. Now, how can this be done? And first of all, I would like to quickly show a video what a dog can do. It's amazing. Now, what are the different elements? Of course, there's a lot of elements why the dogs can do this, but from the actuation principle, from walking, it's mainly that they have muscles and tendons, and the muscles and tendons are elastic. So you can interact with the environment in not a rigid way, but very elastic way. And what we do with mobile robots, walking robots, imitating this and trying to do this in a technical way. So what we do instead of the muscles, we have motors, electrical motors, and instead of the tendons, which are elastic elements, we have springs. These springs allows, on one side, to really recover energy. If you stop down on the ground, the spring is deformed, and you can get up the energy again. So these machines can be much more efficient than other machines which don't have springs. On the other side, the springs also protect actually the motors behind, because the impact with ground contact is much slower. And then the deformation of the spring is a perfect measurement of the forces you are acting on the environment. So if you do this with a robot, here this spring is integrated directly in the modules. We have each leg has 4 motors and 3 motors, and each motor has a motor and then also a torsional spring, which makes this element elastic, so it can much better adapt to the environment, has somewhat a soft contact with the environment, and can then do a lot of maneuvers which you cannot do with wheels, and which is also very difficult with tracked vehicles. And here you can see this is something which is quite difficult for robots. With wheeled vehicles, there is no way to climb upstairs like this. With tracked vehicles, you can probably do it. And of course, if you have the springs in the system, you can actually also preload the springs and then start to make big jumps with these robots. So this robot is not optimized on big jumps, but it can actually be optimized, and it will hopefully be able to jump even higher in the near future. The second element you need if you want to interact with the real world, be it as a robot or as another type of machine, you have to perceive the environment. And in the last 30 years, there have been wonderful new sensor technology which came out, which allows now today really to have robots moving around, autonomous cars, for example. This sensor, Velodyne sensor, is the sensor which is the principal sensor to make Google cars so efficient and so reliable. This is a 3D laser. We have a laser beam which is actually measuring the time of flight, so measuring how long it takes to get to an object, reflect there, and come back. So you pulse a signal, and then you measure how long it takes. This is nanoseconds. It's very fast because it's speed of light, but on the other side, today, your computers are also running in a frequency in the same order of magnitude. This is today possible. Then you have multiple sensor beams, laser beams, and then you turn it, actually. So with this, you have one dimension, and then you turn it about 30 times a second, and so with this, you have a depth information you can recover with this sensor. Now, once you have one measurement and you have a second measurement from another place, then the next story is how to put them consistently together. And if you have the appropriate algorithms, you can actually come up with a map, which is here mapped from outside, around, and inside ETH Zurich, where we moved around with the sensors, and we took different measurements, and then the algorithms we developed were able to bring them very precisely together. So you had a consistent 3D map, which is then a perfect base actually to navigate in this environment. You can see here, the nice thing is that you can really do it outdoor, indoor, and using this sensor information then as for localization, or in parallel also for collision avoidance, so that the robot doesn't collide with the environment. And you can also have different resolution. So this is how it's then used, for example, on a car. This is exactly the same what Google with their car does. We have the white points, which is the map which has been built beforehand. So you move around with the laser, you build a map, and then the colored points are those points which are matched with the map, but from the actual measurements. So the robot is taking measurement, tries to find the best alignment of its measurement with the map, and if this is good, then it knows where it is in relation to the map. And of course, this depth information, because it's pretty fast, it allows also to do collision avoidance, so the robot doesn't collide with its environment. So these sensors from the laser sensor are quite expensive, bulky, and heavy. For example, this sensor you cannot fly on small drones. Another sensor which evolved in the last years, and the calculation power which is necessary to treat the signal, are cameras. You have cameras everywhere. You have cameras in your smartphones. Now, what can you do with cameras? One disadvantage with the camera is that if you have an image, you project the 3D world on a 2D planar image plane. So you're losing actually depth information. But for collision avoidance and mapping, you need actually depth information. But you can do this with a stereo camera. If you have two images, probably you know how to do this in a geometric way. But on a mobile platform, you even don't need multiple cameras. If you have one camera and you're taking a picture from here, you move further, you take a picture from here, and then you try to find feature points in the image which are in both images. And of course, this is then the tricky part, how to define these features, which are the most appropriate features you can find again in the next image. But if you do this well, you can actually recover then the motion of the camera. Once you recover the motion of the camera, you can also recover the depth and the distance to the sensor, and all of a sudden you have a 3D map. And with this 3D map, we call it a feature map, which is only consisting of these features which are sticking out in the image. You can then do this on a smartphone or a tablet. And this is a collaboration with Google on the Google Tango project, which will actually be a presentation just after this one in the other session, where we can go on a roller coaster and actually track features from one image to the other. And we need additionally the IMU, which is the angular rotational sensor and acceleration sensor, which each of all your smartphone has involved. And then you can actually do motion estimation on the roller coaster in real time on the tablet. So you can see the colored points are the points which are tracked from one image to the other. The lower part is actually the acceleration and rotational speed of the system, which is another sensor you have on your smartphone. And then on the upper right part of the image, you can see the estimation of the motion. After about 700 meters, you have an error of about 2 meters, and you can actually still correct this by actually trying to find features you have seen in the beginning and corresponding features where you are, and then you can close the loop, how it's called, and then you have a consistent map of the environment. So this is to appear on your tablets and smartphone. The first tablet which has some of these features already on is already out from Lenovo. And what you can do, you do feature tracking, but then you have also a depth sensor, which is a new type of sensors you probably know from Kinect sensors, which directly gives a 3D image. And if you put them consistently together, you can actually just move around or wave around your tablet, and you have a 3D map of your environment. Now, what can you do with this? Of course, on one side, you can then actually combine virtual and real worlds. You just put elements in your real world, because you know precisely in 3D your real world. You can, for example, go and select a new couch for your home, and then you put the couch, which you take from the internet, in your home, and you can see how it looks like. So there's plenty of opportunities coming on there, because these systems have now the intelligence at least to localize and to build the environment in 3D. Now, of course, there is still not the end of the story. At the moment, we are still not able to really have the capacity to analyze, to understand situations, to really understand what people are doing in the environment. And so the next step, of course, what is in the last years coming back, which was actually already done about 30 years ago, but then the calculation power wasn't available, using, for example, neural networks to train and to learn from different situations. And this is somewhat a primitive copy of what the human brain does. And you have then a lot of learning examples. And what you try to learn is more or less the function between the input, which in this case we will just see is an image. And the output is we would like to segment and to classify the parts of the image. You would like to know where is the street, where are the bushes. And you can see here how this already can work pretty nicely. So this is now a classification of a street scenario where you can see the street signs, you can see the bushes and trees and the different signs on the street. So this is nice progress, which will drive a lot of fields forward, not only robotics, but all this field where you have to understand and analyze information. The shortcoming still with this is that you need a lot of training examples. And the training as example means that you, as a person or somebody, has to annotate the image, has to first show the machine or the machine which learned which is actually a street. And this is not so obvious. There are some tricks you can also actually learn on synthetic images which can be generated, but still is a big issue. And so the question is now, how can we generalize from a lower number of data, which humans can? I can show you a new object which probably you have never seen before, and then you learn it typically with 1 or 2 examples, and you can generalize it to examples which look similar and have the same functionality. There's still a lot of work to do until this system really can understand the environment. So I would like to, before I'm coming to a little bit the future where it's heading to, show in this example where a flying robot is interacting with a ground robot, and it shows more or less where we are today. This robot, the flying robot, is doing this feature interaction, so it knows always where it is. Then it also reconstructs a dense map, so a very precise map of the environment, as you can see it here. And then this information is downloaded to the ground robot. The flying robot can much faster go around and fly over the obstacles and give then the information to the ground robot. The ground robot can find the optimal path on the information it got from the flying robot and then start to move towards the goal which it should reach. The ground robot has, of course, also its own sensor, has some additional sensors because it's more precise and it can actually carry more heavy and more power using sensors. And then, of course, it can adapt its path. For example, if you put all of a sudden a new obstacle there or a human walks into it, it will automatically adapt its path around to the goal. So how will robotics move forward? So I tried here to put somewhat on a graph and also with some guesses about the timing where we are. On one axis, you can see the complexity of the environment. The very simple way is a gym hall, for example, which can be represented by 2 dimensions. It's more or less flat, and the walls are straight. And the other extreme is highly dynamic 3D environment, where we have a lot of different elements in the air and on ground. So the more complex, the more difficult it is on this end. And the other end is the complexity of the interaction with the environment. So starting with pure navigation, only moving from A to B, then to have advanced interaction, speaking or interacting with people, and then, of course, once you start to have arms that do manipulate things, and then you have tactile manipulation. The example we have seen in the beginning, which is robot cleaning the kitchen, is actually rather tactile manipulation. This is a very difficult task, and you can see up at the top in the middle, it's household universal. Probably the robot you would dream of, cleaning up your home and making everything nice without your intervention. This is far down the road. On the other axis for autonomous cars, today technology is ready to drive on freeways because they are pretty structured and they are not so complex. You can consider them nearly 2D. You can probably also drive autonomously in parking lots, but if you want to really go to a big, messy intersection where people have to give sign and make contact with the eyes, this is still not feasible. So Switzerland and Europe, I think, has a lot of opportunity in this field, and in Switzerland we have a lot of activities like National Center of Competencies in robotics, also in digital fabrication, which is about using robots for building houses, or collaboration with the Max Planck in Tübingen and Stuttgart about learning systems, or then also technology transfer like the Wies, Zurich, or the Innovation and Entrepreneurship Lab. I think we have a very large density or strong density of startup companies. You can see here a big list from companies which are doing medical robotics, nanorobotics, up to autonomous cars and similar stuff. And we have a lot of wonderful collaboration with industry. For example, having Disney Research Center on the campus of Zurich, or Google and ABB, GoPro, and so on, which are allowed to push this technology forwards, and which also allow our startup companies to go faster because they need partners for really penetrating the whole world. So in conclusion, robotics is booming, but I think there are still a lot of open questions because the real world is much more complex than the data world where somewhat a simple description of what you have. Europe, and especially Switzerland, have the large potential to really become an important player in this field. We have the top research at the universities, we have great talents, and we have a lot, and this is one of these events, a lot of this entrepreneurial and innovation spirit which moves this forward. What we still need to move forward, I think, is a little bit more risk-taking culture and risk-taking also on the financial side. We need long-term investment. a startup company in robotics cannot be profitable within 3 years and do a large market success because it's very complex. This you can do if you're doing an app, if you're doing it well, probably in 2 or 3 years you are very profitable. This is not the case with systems which have a lot of also hardware involved. With this, and the last slide I would like to end, I would like to make a little publicity for the Kickstart Accelerator, which is one element where we invite especially startups, young people from outside all over the world in different fields, especially also robotics, to join us during the summer from middle of August to middle of November to work together and to move forward. And I think the specificity about this Kickstart Accelerator is that we have a strong involvement of big corporates which actually meet these young startups, offer them proof of concepts projects and so on. With this, thanks very much for your attention, and if we have time, I'm happy to answer some questions.
Thank you, Roland. Thank you very much. We have time for 1 or 2 questions for Roland. Yes, here we go, right up front. You don't have to throw it far.
Hello. Yeah. I just would like to ask a question about the military. The military has the system since long time. What about the military today?
Yes, of course, military is one of the applications field where there is a lot of interest. In US, an important part of the research is also financed by military. Happily, in Europe, it's not so extreme. All technologies can be used in different fields. Hopefully, and I have probably one extreme dream could be probably at one point we have only wars between robots and not humans involved. And then the better technicians, which have the better robots, are the winning teams. And hopefully this technology will not be used for the bad, but for the good for the society.
Last question.
Okay, one more, yes. And we'll give it to somebody else. Yeah.
Yeah. Just a last question. What about if the robots cannot interfere with the humans anymore? The humans cannot control the robots anymore, and they cannot turn it off for some reason.
Science fiction could be real.
Yeah, this is science fiction. I'm not so worried that this will happen in the near future because robots are different. These are machines which need power, and if you take the plug off, it's finished. We are biological humans which are quite different in their motivation and so on. So I think we don't have too much to worry about this, that robots will take over power.
Okay. I run on battery power, by the way. Yeah, you got to find the plug. One more question. Going once? Going twice? Okay, Roland, thank you very much. Very
Thank you.
Interesting. Thanks so much. Okay, good. Now we have a panel discussion coming up. Where is mobility heading? Okay, so Rasul Yalali is Managing Director of Uber Switzerland. He was here with us last year. Frank Rinderknecht is founder of Rinspeed. Anders Tillman Mikiewicz is involved in Volvo Monitoring and Concept Center. And the panel will be moderated by Alex Flamont. He's an early-stage machine learning investor at Notion Capital. Gentlemen, the floor is yours. Good luck.
Great. So thanks a lot to everyone for joining us for this panel on mobility. We hear a lot about autonomous vehicles, the net impact and benefits they're going to have, but it's really about the future of mobility and the benefits that's going to have. And we're really lucky today to have 3 amazing panelists, which will try to kind of understand why we're here today, what are the benefits we're going to have in the future, and what are some of the roadblocks or constraints that we're facing then. So one of the questions I'd like to kick off with you is we hear a lot about autonomous vehicles, mobility. Why now? What's changed? What makes 2017 a prime year to be talking about this and investing in this?
Well, it's a good question, actually. We started showing autonomous driving already 10 years ago with our most famous car, our icon, the Scuba, the one which could go underwater. But the time in 2007, 2008 just wasn't the right time that people would take it up. Of course, there is a lot of technologies now which we have available, which at that time was not like drive-by-wire and all these things, plus all the IT backbone which you need to drive autonomously. And for any product, always in life, timing is crucial. If you're off, if you're too late, if you're too early, it simply doesn't work.
Okay. And in terms of a timeline or an expectation, do you have a time where you would expect a level 4 autonomous vehicle? And maybe you can explain to our audience what a level 4 autonomous vehicle entails.
Well, level 4, just to quickly explain, is that when you can take your hands off, but you still maybe should pay some of attention. And level 5 would be like the famous Google pod, which just drives by itself. I mean, it all depends on what the circumstances are. If you go down to New Delhi, downtown, 6 o'clock in the evening and drive autonomously, believe me, that's far, far, far off. If you go over a controlled highway, a Autobahn, Zurich to St. Gallen, probably 2020, that's about what people or the OEMs say when it could be happening in view of technology, but then there are regulations, of course, there are liabilities to be solved, but ballpark figure take 4 to 5 years under controlled highway circumstances and then gradually moving to the urban areas and in the cities. And it's so complex. I mean, you don't have interaction on freeways, but in a city, you need to then exactly understand what that means. If you think I just mean for you to wave to pass over,
right,
and I just talk with my hands as I do, then it's a fatal mistake you do. So it's still ways to go that it's working as reliably as we think it should be.
Sure, and I think this kind of segues into some of the work Uber's been doing. So I guess the first thing that comes to our mind when we think autonomous vehicles these days is passenger-driven vehicles, but Uber, which clearly is involved in the space, has also been doing a bit more. Can you walk us through the strategy of why going into shipping and trucking and then going into, at the same time, moving people?
Yeah, so I mean, you started your first question with, why is 2017 the year for autonomous? I think we kicked it off in 2016, and we actually sent a truck across the U.S. Filled with Budweiser beer, and it drove autonomously the whole way, right? So, but that's to Frank's point, that's mainly on a highway, right? So basically means that you drive on one lane, you accelerate, you brake. The other thing that we do is people transportation in a city autonomously, and some of you might have heard, maybe even seen, maybe even experienced in Pittsburgh. We're testing this today. So, we have the opportunity already today to go to Pittsburgh, order an Uber, and with a little bit of luck, you will end up in an autonomous vehicle. You still have a safety driver behind the wheel. That means there's still someone sitting behind the wheel and basically not touching the wheel, but being ready to intervene if something, goes wrong, or, you need to brake or whatever that you might realize. So, yeah, I think we're in these two different scenarios. One is, trucks driving individually, autonomously, and normal passenger cars within cities. And I think the challenges are a little bit different. The complexities are different. But, we can do both at the same time. It's super interesting times.
And I think one of the points worth mentioning is these cars driving themselves, essentially in Pittsburgh for Uber, are Volvos. And it's interesting to see how companies like Volvo, and this is a drastic shift that's going to change vehicles as much as mobility was changed from going from horses to mechanical horses and cars. The next shift will be as significant. It's been really interesting to see, and chatting with you backstage, how Volvo's reacting quite quickly and almost thinking like a startup in the way that they go to market and the value add that they want to bring. Would you mind sharing a bit more on how Volvo sees the future of mobility and where you guys come in?
Sure. So in the area of autonomous drive, we're kind of attacking it three different areas at once. We have the collaboration together with Uber. That is to create the hardware that's needed. We have the software. We have the Sinuity, which is a collaboration with Autoliv, that we spin off. And then we also have, which is, I think, is almost the most interesting one, at least for me.
Yeah.
That is the Drive Me pilots that's happening in Gothenburg right now. And that's where you actually put the human component into it. And you actually learn how that works in real life. How does it create value for a human? And as you move towards the level 5, what is really the value add? And because it's not just technology, it's not just hardware, it's not just software, it's a big human component into it. So we're doing those three. And the last couple of years, I've been in California, and we've been exploring the value component of it. If my colleagues in Gothenburg is successful and the collaborations are panning out, what will it actually means when the car can drive itself, when you don't have to supervise it? And that is, I think, why we're all here, why all the companies are so invested in it. That's why I think it's relevant for all of you guys to start thinking about it. Because when you have access to that time, we capture that in what we call Concept 26. What was essentially the average commute time in the US one way. And that was about how do you unlock that value, because you can look at all the different areas where you can unlock AD, and some of it will be reachable quicker, and there's lots of technology to it. We kind of attacked it, where would it add the most value first? And there we see the ring road around Gothenburg is where people spend most of their commute, so that's a good place to start where the value lies. If we can unlock that time for them and they can spend it on other things than just watching traffic, that's big. So that's one component to it. And then really, how do you go from there? And I think that's when it gets relevant for a lot of other people to start acting on that, and co-creating new value on top of it. So that's what we're doing.
Super interesting.
Yeah.
And then to get Uber's take on this, what's Uber's vision for the future of mobility in terms of the kinds of cars we're going to have, the relationship you have towards the car, and maybe what are the benefits that would unlock?
So one of the things, when you talk about cars, a lot of people start to jump to a conclusion that the car is bad and, it's creating pollution and all these kinds of things. Or I think you need to distinguish a little bit. Yes, it is true that on average, in the commute time, you have, like in Switzerland, 1.1 people sitting in a car driving to work, basically meaning that, there's only one person in a car that could actually fit 5. You're not using the resources properly. So it's easy to demonize the car as such, but it's actually not the car, it's the way we use it, right? We use it as, one person, one car, and that we need to change, for sure. So my belief is that the car of the future will be shared. We're doing this already in a lot of cities, in a lot of countries, and there's just going to be more of this because we need to use that resource in a way meaningful way than we're doing it today. And we have the technology already available. So it means that we need to make use of that. We need to start sharing the cars. And if we have the autonomous part of the car, that gives us one more seat in that car. And it also helps with the sharing part, because that car could be driving around, picking up people, dropping off people constantly. It frees up parking space in the city. It creates less pollution. It uses less space. And, in this ecosystem, shared cars, autonomous cars, and, I hope so also electric cars will go hand in hand.
Okay. And I guess for you a question would be, so this is the vision, this is where we want to go. What are the major roadblocks? Is it regulation? Is it some technological components? What are the major roadblocks today stopping autonomous vehicles from being a thing in 6 months or a year?
Well, before I answer that question, I'd like to come back to Rasul's statement. I think you can take it even on a higher level. I think the future of the consumer is governed by either experience or convenience. Things have to go really smooth, fast, easy, comfortable, and probably cheap. I'd like to illustrate that with a typical example. You'd like to buy an apple. You want to go to the store, and you want to choose it yourself because it smells nice, you want to touch it, you want to see it, feel it, and you want to see whether it doesn't have any dents. So it's the experience. But then the painful way starts because you have to put it in a bag, you have to wait, you have to stand in line at the cashiers, and you have 4 people in front of you who first pack everything in and then look for the money, and every 5 cents they bring out, and that's negative. So you have to concentrate on the positive, and mobility in urban, commuting, going to meetings, whatever, needs to be convenience. And it's not associated with joy of driving anymore. As we learned it, maybe at my age, I'm a dying breed of V8 generation, but young people look at it completely different. So you have to offer convenience in mobility, that you can move around swiftly and easy. And to come back and address just with one flow to your question, I think the main obstacle is us. It's not technology, because we have executed mobility for 125 years or so in one way. We used to own a car, and of course you have to differentiate between urban and extra-urban areas, which, extra-urban still is a different issue. But that we unlock our thoughts, that we could share a car, that we could use this kind of a system, I think the main obstacle is really up in our heads, especially for the elder generations, and then move forward and to take like a guinea pig, so to speak. My daughter, 25, she even doesn't own a car anymore, despite I bought her one, paid almost everything, and she just gave me back the key and said, "Daddy, keep it, I don't want it." So it's a different perception of the elder generation than the younger generation as well.
Yeah, and it's not even just a generational gap. So when we look at China, for example, where there's a lot of families that have never actually owned a car, being driven is actually seen as a status symbol as opposed to driving. And it's systems where you'll get a car if you can have the driver, and if you can just not have the car at all, it's quite interesting. But one more point I'd like to ask you is that, so I was looking on your profile, and your first Geneva Auto Show was in 1979. You've seen quite a bit over the past few years in terms of not only safety coming into vehicles, but also in autonomous these days. What's the one thing that excites you the most about the impact that autonomous vehicles are going to have on the way that we live, the way our cities are shaped?
I think to drive autonomously is just the beginning of a completely new industry. I mean, people are investing now billions and billions and billions into sensors, into AI, into actuators. And in my thesis, why not take it to all different fields of life? Not only, in mobility in a car. For me, a car is basically a word of the past. I'm still trying to, and I'm open to suggestion, define the vehicle of the new times differently. And I think will just pull off a big, big wave into automation in all aspects of our life.
And
maybe if I can add something to that as well. I think there's going to be a multiple kind of growth of value into all different kind of sectors. I think there's cases where the stuff you guys are talking about, where it makes sense to share, and I think it's a great way to experience Volvo with 5 people in the car. I think that's a great way, but we kind of look at it differently as well. We see that autonomous drive and connected cars actually enables personal mobility to be much, much better than it is today. So if you take the case of a younger person living in a downtown area, they experience Uber, they experience Uber Eats, they experience Amazon Prime Now, they experience all of that. And I see that as a gap in experience, right? So that's why we're doing what we do in the Bay right now, where we have a pilot ongoing for Volvo Concierge, where we take the friction out of ownership as well. So I think there's a lot of untapped potential where you can take away the friction points of owning a car. And that doesn't mean that that's going to be the only way you consume mobility, but we see a huge value proposition in that, and we see how that gets a lot of traction. So what I think is what will happen is that I don't know what's going to happen, but I know we can crunch so much more in making personal mobility because there's so much strong stuff in that. And when we did Concept 26, we didn't see that, yes, sometimes people don't want to drive because they want to do other stuff. But at the same time, we see how customers actually love to do it sometimes. And we don't believe in taking away something that people love. We think about adding a component. So whatever this will pan out to, I think it's hard to say. For certain people, I'm perfectly sure that alternatives to ownership as we know it today will definitely change. But I think there's value to be created in the whole span. And we believe also in personal mobility. And we think that's going to be a very, very exciting proposition going forward. So check out that with Volvo Concierge.
For sure. And when can we get Volvo Concierge in Europe?
Well, that's on the next one. We can talk about it. I'm also here to meet you guys and to making that a reality as well.
Sure.
So just like with all of these, it's where tech meets basically market. So I spent the last 5 years in Silicon Valley and in California and in the US, where companies can spread really, really quickly. And they can be enabled by technology just like Uber. And then they can reach that. So we're collaborating with them here. I am here to meet companies that could be our potential partners for Europe as well. And there are a lot of good companies here, so stay tuned.
Yeah, and as a bit of self-promotion, speaking of really good companies, make sure to check out 5.ai, an autonomous vehicle company based out of Cambridge, where we were lucky enough to invest in, which I will be introing to Volvo and Uber. But I guess back to you. Clearly, this is a space you've been in Volvo for over a decade. You love what you do. You love autonomous vehicles, and we were just chatting about what an interesting time to be working in this industry. Same question I had asked, but what's the one thing, not even at a Volvo level, but to you that just fascinates you about what the future might look like in terms of mobility? Yeah, for you.
I think the future for mobility is, if I look like 10 years, 15 years down the road, it's that Amazon, Alibaba probably will dominate the mobility market out of the simple reason, nothing against Uber, but they have hundreds and hundreds of millions of customers. They know them, they do logistics, and in my opinion, if I look down the convenience road, why don't they serve also those customers with a seamless mobility? And seamless mobility for me means that my whole journey is done at the tip of a finger. It's like charged, like on my mobile phone. I don't need to go to a foreign city and worry about getting a train ticket, not knowing how to get it, or languages or whatever. And this convenience thought, again, will be very strong in mobility industry. And if big players, as a thesis, like Amazon, Alibaba, enter the market, they have the strength to dominate, to say, dear SBB in Switzerland or whatever, St. Gallen, Stadtwerke, you have to cooperate because we are so big. To take like an example from today's hotellerie, which is booking. If you own a hotel today and you're not with Booking and TripAdvisor, you're more or less dead. So that's the power of a platform. And Uber, of course, Lyft, and whomever will be part of that system, because Amazon cannot do the system, but they will combine the system for a seamless travel.
Interesting. And so one thing with Uber that's just fascinating is, as you would think of Google starting as a simple search engine and then expanding into many verticals, when you think of Uber, which was an app that connects you to drivers and is now, after the acquisition of Otto, can do the really important things like ship a freight of beer across 2 cities without a human driver on it. What's next for a company like Uber? How far does this go, and does it get vertically integrated, or where does the future take Uber?
So I mean, for us, it makes sense to look into autonomous driving, right? We are a technology company that, yes, started as an app where you could, by the tap of a button, order a ride. Now, looking into the future, that ride will be autonomous, for sure. The question is, when will it happen? And I don't have an answer to that. We won't have an answer to that. But we know this is going to happen. And you asked in an earlier question, why are we doing this? Or why are companies doing this? And I would actually argue that there is no reason not to do it, for the pure fact that you have more than 1 million deaf people on roads every year in the world, and that's reason enough to do this. Because as soon as you have autonomous driving that works, you will have almost all of this gone. So that's the reason why you have to do this. If you're a technology company and you're in the mobility space, that's not a choice. Like, you have to be on the forefront of this, and you need to innovate. And that's what we do, and we think we're doing it well. It will take a little bit of time still. But we will develop in a world where it will be very normal to do so.
Yeah, so I think I completely agree with what you were saying. One of the foremost factors that kind of motivates us to get into the industry is the stat you were saying comes down to about 3,400 people dying in a car accident every day around the world. So every year, every week, every day that you can bring autonomous vehicles a bit closer, which are cars that don't drink, don't fall asleep behind the wheel, don't break the rules, don't speed with their friends. Every day that you can bring that closer is just hundreds and thousands of lives that you'll save down the road. But with that in mind, I guess this is an open-ended question, and maybe for Volvo it would be most interesting to answer it is, let's assume we, in a number of years, get to a world where, yes, cars can drive themselves. I can go to work with my car from point A to point B without having to touch the steering wheel. But where does that put the inherent pleasure of driving? Does it become what riding a horse is, where I go to the stables and rent a really nice horse, have a good time? Or do I, is there still a room for me to drive my car from point A to point B? Or is that actually too much of a risk hazard and becomes banned? Or where do you see that going?
Well, me personally, sure hope not.
Yeah.
But I think what you'll see is a lot of, just like the companies that are sitting here, I think you'll see much more choice for the user. I think that's what I hope. I hope it's not about taking away, but rather giving options for people. And I think the closer you can do that, and what it enables with autonomous drive and connected cars for us, is about creating a much more custom choice. It should be easy to approach Volvo. Today, you can go and buy a car, or you can use our Sunfleet, for example, to get it there. You could imagine it being much, much easier to get into having a Volvo. It will mean a lot more choice when you have that car. So you can either choose to go end to end, through an autonomous Volvo that takes you from A to E, when that makes sense. Other times you might have a choice to do something else. You can get your packages delivered to Volvos already, and in Switzerland we launched just now with some really good partners. So Switzerland, outside Scandinavia, I think is the first market where you do that. Sometimes when you're gonna get that stuff delivered to your car, you're gonna wanna have a car available. So you can be in here and get all that stuff delivered outside, and then you go directly to whatever party you want. And you got your food, you got your wine, or you got the gifts that you have in there. So I think it's about, you'll see a much, much greater variety of choice for getting that done. And that's what really excites me. So I hope not that we will take away choice. I think we as Volvo, safety is always kind of the pillar we build it on. So for sure, we're going to reach Vision 2020, and that is that no one will be seriously killed or injured in a Volvo, and we're on path to reach that. So we can contribute by people having our products. We like to contribute even more by spreading that. But I think it's about choice. I think there will be much more choice, and whatever those choices are, I can't tell. If I knew what was going to happen in 10 years, then I would go and do that. I know what's happening right now, and that's a direction we see going. And that excites me a lot, that you'll have much, much more choice, and those choices will hopefully have a much better fit on your life. It will be, you don't have to fuel up your car, you don't need to wash it, you can get it sent somewhere. So if I want to go from A to B with my car, I can, for example. That's the stuff we're working on now. How that will pan out, I don't know. That's why we're piloting, just like a startup has to go out and uncover unknowns and try to build basically validated learnings. That's what we're doing, because we don't know. But we're really excited about the possibility of that choice, and we're exploring that very, very aggressively right now. So that makes it fun to work at Volvo.
Great. So I guess before we go, just wanted to wrap up and say, this is clearly a space which is disrupting a lot of industries. Obviously, the first one that comes to mind is the auto industry and logistics and things like that. But the impact this is going to have on insurance, with car insurance being one of the largest markets, logistics, shipping, healthcare response is immense. So if this is something you're interested in, make sure to read up on those fields as well. But please welcome me in giving a huge warm applause to our three amazing speakers. And if you're interested in learning a bit more, make sure to catch them after for a bit of Q&A. Thank you for your time. No one forgot anything?
So back at 11:30. Yeah. Okay. We were going to take a break now, and we will be back here at 11:30 with Christopher Weisbach, who will show us how a supercomputer shares new boundaries. Back here at 11:30. Thanks.